Okay guys, so today we're going to look at the laws of exponents. We use the law of exponents to simplify exponents, expression that contains exponents. So, if I have 3 to the fourth, this would be 3 times 3 times 3 times 3, which is equal to 81. So basically, we're going to use exponents for repeated multiplication. So let's look at some vocabulary. If I have 5 to the power of 3, 5 is called the base, 3 is called the exponent, and like I told you before, we use exponents for repeated multiplication or repeated factors. So the first one that we have here, it's called exponential form. Okay. Well, this is a exponential form, so if I have x to some power, then this would be x times x times x n times. Okay. Okay, so if I have x to the power of m times x to the power of n, this is equal to x to the power of m plus n. So if you're multiplying powers with the same base, you keep the base and add the exponents. This is an example here. If I have 2 to the power of 6 times 2 to the power of 3, okay, this will be 2 to the power of 6 plus 3, which is equal to 2 to the power of 9, which is equal to 512. Okay. So if we have the same base, you keep the base and you add the exponents. Okay, dividing powers. Okay, so when you divide powers with the same base, you keep the base and you subtract the exponents. If I have x to some power over x to some power, I'm going to keep the base and I'm going to subtract the exponents. This is an example. If I have 2 to the power of 6 over 2 square, because I have the same base 2, I'm going to keep the base and I'm going to subtract the exponents. So this is going to give me 2 to the power of 4, which is the same thing as 16. So when you divide powers, you subtract the exponents. Okay, next we have a power rule. Okay, so if I have x to the power of m, everything to the power of n, you keep the base and you multiply the exponents. You multiply the exponents only if you have a power of a power. And this is an example. If I have 5 to the power of 3, everything to the power of 2, raised to the power of 2, I'm going to keep the base and I'm going to multiply the exponents. So this would be 5 to the power of 3 times 2, which is equal to 5 to the power of 5. Okay, this is supposed to be 5 to the power of 6. Let's change this. This is not a 5. This should be 3 times 2 is 6. Okay. So when you take a power of a power, you multiply the exponents. Next we have the product law of exponents. So if the product of the bases is power by the same exponent, then the result is a multiplication of individual factors of the product, each power by the given exponent. And this is an example. If I have x times y to the power of n, this will be x to the power of n times y to the power of n. So what you do, basically you distribute the power to each factor that's inside the parentheses. And this is an example. If I have a times b to the power of 2, this is going to give me a squared times b squared. So when I take a power of a product, I apply the exponent to all the factors of the product. Then we have the quotient law of exponents. If the quotient of the base is powered by the same exponent, then the result is both the numerator and the denominator each powered by the given exponent. And this is an example. If I have x over y to the power of n, this is equal to x to the power of n divided by y to the power of n. So what you do, you take the numerator and raise it to the power, and you take the denominator and raise it to that power. And this is an example. 2 over 3 to the power of 4. This is going to be 2 to the power of 4. So the numerator is going to be to the power of 4 divided by the denominator to the power of 4. This is going to simplify to 16 over 81 because 2 to the power of 4 is 16 and 3 to the power of 4 is 81. So make sure when you take a power of a quotient, you apply the exponent to all parts of the quotient, the numerator and the denominator. Negative law of exponents. If the base is powered by a negative exponent, then the base becomes reciprocal with the positive exponent. So if I have x to the power of negative m, I'm going to write this as 1 over x to the power of m. So to make it a positive exponent, you will have to write it over 1. And this is an example. 5 to the power of negative 3, this will be equal to 1 over 5 to the power of 3, which is equal to 1 over 125. If the negative exponent is in the bottom, you would put it in the top and make it a positive exponent. So if I have 1 over 3 to the power of negative 2, this is going to be equal to 3 squared. So this one goes in the top, which is equal to 9. So basically what you do, you switch them around, the reciprocal. Okay, so you can, if you want, you can put it as 3 squared over 1. You just switch them around. Okay, you just flip it around and becomes a positive exponent. Okay. So if the base with a negative exponent is in the denominator, it moves to the numerator to lose its negative sign. Okay, that's like what I did here. And then we have the zero law of exponents. Any base powered by 0 exponents equal to 1. So if I have x to the power of 0 is equal to 1, 5 to the power of 0 is equal to 1. If something inside the parentheses to the power of 0, that gives you a 1. Okay. So keep in mind anything to the power of 0 is equal to 1. So 0 factors of a base equal to 1. Okay. Let's look at some examples here. Okay, so we're going to simplify this one. I have addition of the same base. I'm sorry, I have multiplication of the same base. So I'm going to keep the base, which is y to the power of 2 plus negative 4. I'm keeping the base and I'm adding the exponents. 2 plus negative 4 is going to give me y to the power of negative 2, which will be 1 over y to the power of 2. because you cannot have a negative exponent. Okay, I have to write it as a, flip them, reciprocal, 1 over y squared. This one here, so I have 2 times 4 gives you 8. Okay. And then I have s to the power of 2 times s to the power of 7. So this would be s to the power of 2 plus 7. This is going to simplify to 8 s to the power of 9. Again, I'm keeping the base s and I'm adding the exponents. That's what I did. This here is an s. Sorry, it's not a 5. Okay. This is an s right here. This one here, we have a negative exponent, so we're going to make it a positive exponent by move everything at the bottom. So I have 3 x to the power of negative 2, y to the power of 3, everything to the power of 4. Now I'm going to distribute the 4, so I have 1 over 3 to the power of 4, x to the power of negative 8, because 4 times negative 2 gives you negative 8, y to the power of 12, 4 times 3 gives you 12. Now I have a negative exponent right here, so this will go on the top. I have x to the power of positive 8. 3 to the 4th will stay in the bottom, and y to the power of 12 will stay in the bottom. So this is how you would simplify this expression. Okay. So if it's a negative exponent in the denominator, you move it in the top, and you make it a positive exponent. Okay, let's look at this one. 7. I have s to the power of 12 divided by s to the power of 4. So I'm going to keep the base and subtract the exponents. I have 12 minus 4. So this will be s. Sorry, my s are not that great. 12 minus 4 is 8. This one here we have 3 to the power of 9. So this would be 3 to the power of negative 18. So we take the numerator and we raise it to the power of negative 2 over 3 to the power of negative 10. 5 times negative 2 gives negative 10. This is going to simplify to 3 to the power of negative 18 minus negative 10. If I have division of the same base, I'm going to keep the base and subtract the exponents. This is going to be equal to 3 to the power of negative 18 plus 10. This is going to be 3 to the power of negative 8. Because it's a negative exponent, I'm going to put it over 1. So it'll be 1 over 3 to the power of 8. This would be the answer for this one here. Last example, I have 36. So I can split this. If you want to do it this way, you will see it 36 over 4. I'm going to split the fraction. Times a to the power 5 over a to the 4th. Times b to the power of 8 over b to the 5. So we can split the fractions. So this will be 36 divided by 4. It gives me a 9. I have a to the power of 1. 5 minus 4 gives you 1. So if I have division of the same base, I'm going to keep the base a, and I subtracted the exponents. And then I have b to the power of 3, because if I have division here again, b to the power of 8 divided by b to the power of 5, this will be b, and then I'm going to subtract the exponents. 8 minus 5 gives you 3. This would be the answer for that one. So this is your ticket out. I want you to simplify this expression, and I want you to message me the solution to these two problems. Thank you.